Hello friends, today, we're reviving my 6th generation Mitsubishi Mirage by replacing its ancient battery. Before we tackle this electrifying task, let's explore 3 ways to find out if your battery is plotting to leave you stranded. First, consider its age. Standard car batteries last 3 to 5 years. The one we are replacing today is 8 years old and original to the car. Talk about living on borrowed time. Next, you can get the battery tested. Most automotive shops will test a car battery for a nominal fee, or you could buy a tester off Amazon like this one, for just 40 Canadian dollars. Finally, check the battery's voltage before starting the engine. Checking it after shutting the engine off is not a reliable means for determining battery health, as even a bad battery will hold a charge for quite some time after the car is shut off. For reference, a flooded lead-acid battery at 50% capacity is 12.07 volts, while a sealed lead-acid battery, including AGM batteries, at 50% capacity is 12.23 volts. Stick around, and we'll conquer the thrilling challenge of changing the car battery, ensuring your ride stays road-ready. No overpriced automotive shop services required. Let's experience the thrill of attempting to start a car with a dead battery together. I am going to start off by turning off the lights and disconnecting the dash cam to give the car the best chance of starting. Now let's put the key in the ignition and put the car in accessory mode. As you can see, my car battery is at 8.7 volts and is rapidly declining, so I'm pretty sure it won't start. Take note of the boot up screen on the radio. Typically, the radio remains on 24/7, like a cell phone, for quick start convenience. However, in this instance, the radio detected the low battery voltage and shut itself down to conserve the remaining battery power. Let's try and start the car. Let's pause the video here and discuss what we just heard. We heard the starter motor spinning, but it didn't sound like it was engaging the engine. To understand why this is happening, let's take a closer look at how the starter motor operates. Here is a diagram from the factory service manual. To make it easier to visualize, I'll use red to trace the path of electricity. Here is the system in its steady state. Note that the B terminal on the starter motor is always connected to battery positive. This remains true regardless of whether the key is in the ignition or not. When the key is turned to the start position, the engine control module activates the starter relay. This causes current to flow through both the pull-in and holding coils, creating a magnetic field that should attract the rectangular plunger. The pull-in coil directs power through an armature, which is essentially a DC motor, and causes the starter to spin. However, if the battery voltage is too low, the pull-in and holding coils cannot attract the plunger. As a result, the pinion gear will not engage the engine, producing the freely spinning starter noise we heard. Let's discuss the ideal battery for the Mirage. It requires a Group 35 battery, and I'll be installing this Energizer AGM battery from Costco. I chose it because they offer free shipping, which is important since my car is currently unable to start. Some people online have discovered that a larger Group 24F battery can fit with modifications to or by removing the battery box. I'll include a link in the description to a forum post discussing this alternative. Checking the starter motor specifications in the factory service manual, we see that the starter motor draws 0.95 kilowatts at 12 volts, translating to roughly 79 amps. The owner's manual advises using a battery with 356 cold cranking amps or more. I would be surprised if someone told me that a battery with fewer cranking amps existed. Now, let's proceed with replacing my battery. Here's a diagram of the battery from the factory service manual. Here are the official steps for replacing the battery. The numbers on the diagram correspond to the steps in these instructions. We will be skipping steps 7 to 11. It is important to remember that removing the negative connection, step 1, must precede removing the positive connection, step 2. This is because the entire vehicle body is connected to the battery's negative terminal. If you attempt To remove the positive connection first and your metal wrench accidentally touches any metal part of the vehicle, you will create a short circuit that bypasses all the vehicle's fuses. Fun fact: some vehicles use a positive ground system where the vehicle body is connected to the battery's positive terminal. You can tell this Mirage uses a negative ground system because there's a plastic cover sitting over the positive terminal, preventing us from accidentally shorting the battery by dropping a metal object, like a wrench, between it and any metal part of the vehicle. This plastic cover also protects the fusible links, which must be present between the battery and devices, further confirming that this vehicle uses a negative ground system. We are going to start off by applying some penetrating oil to the battery holder and terminal nuts. Contrary to what I did, it would be safer if you remembered to flip the positive terminal cover back down. Now, we'll take a 10mm wrench and loosen the negative connection just enough to remove it. There's no need to completely remove the nut. Now, let's loosen the two battery holder nuts. Complete removal should not be necessary. Once they're loose enough, you should be able to pull on the bolts, moving their hook-like ends out from under the battery tray. As shown here, the battery holder consists of these two J-hook-shaped bolts that grip a notched area on the bottom of the metal battery tray. Now, we'll take our 10mm wrench and loosen the positive connection just enough to remove it. There's no need to completely remove the nut. Now it's time to lift the battery out. I'll remove it together with the battery seat, as it's easier to handle that way. Now let's examine the battery seat, often referred to as a battery box. Notice the hole at the bottom of the box and the matching hole in the metal tray it sits on. These allow battery acid to drain onto the ground. Also notice how the box has taller walls on the front and left sides to protect the battery from engine heat. In luxury cars, they actually place the battery inside the cabin to maintain an optimal operating temperature. The factory service manual states that the battery will degrade at temperatures above 55 degrees Celsius, which makes perfect sense, considering the thermostat in this car doesn't allow the cooling system to operate below 89 degrees Celsius. Lucky us, right? Now it's time to clean our terminals. The owner's manual recommends using baking soda and water if corrosion is present. Additionally, special products are available for this purpose, but I'm going to use brake cleaner applied to a towel. Remember not to spray brake cleaner directly on the cables, as it can degrade their insulation. Let's take a quick look at how the battery seat is held in place. The battery seat, which goes in like this, has two plastic cylinders under it that fit into holes on the metal plate below it. Here's a quick look at one of the notches that the hook-shaped battery bolts hold onto. Now let's install the battery seat, taking care to ensure that no wires get trapped beneath it. Now, we will place the battery in its seat, being careful not to trap any wires underneath. Observe how the battery remains securely in place within the seat and cannot slide in any direction. This is thanks to the pegs located beneath it, which we mentioned earlier in the video. Without the battery seat, the battery could potentially slide side to side, causing a short circuit if the battery holder were to touch the positive terminal. Now, let's reinstall the battery holder. Since my new battery is slightly taller than the one we're replacing, I'll need to loosen these bolts first. Make sure not to trap any wires between the battery bolts and the seat. Here you can see the hook end of the forward battery bolt grabbing onto the tray. These bolts should be tightened to 35 inch-pounds. Here's a quick look at the front and rear battery bolts. Notice the notches in the battery tray they fit into, and also observe how no wires are trapped between the bolts and the battery. At this stage, if you're interested in spending a bit more, you could purchase anti-corrosion washers to place over the battery terminals. The one shown here is available for around $7 on Amazon. Now, let's remove the protective cap from the positive terminal on the battery and connect the cable. This should be tightened to 53 inch-pounds. Before we proceed, I'd like to take a moment to demonstrate how safe working with these 12-volt batteries is. I'm going to take my sweaty hands and simultaneously touch both the positive and negative terminals. As you can see, nothing happens, no pain, no shock. Working with 12-volt systems is much safer than some unscrupulous dealerships and mechanics might have you believe. Now, let's remove the protective cap from the negative terminal on the battery and connect the cable. At first, the cable didn't fit, so I loosened the nut a bit more and gently tapped it with the handle of the ratchet. This terminal should also be tightened to 53 inch-pounds. For the more attentive viewers, you may have noticed that I haven't used a torque wrench in this video thus far. This is because I decided to retrieve my torque wrench only after installing all the bolts, as I usually would for other types of maintenance work. The following segment serves as a demonstration of what you should avoid doing. In this segment, you can see me tightening the positive terminal while the negative one is still connected. Observe that there is less than half an inch of clearance between my metal torque wrench and the battery holder, which is effectively connected to the negative terminal. If I rotate the wrench too far or position it at an angle, the wrench may short out the battery. This short would also bypass all fuses, as fuses are only present on positive wires in our negative ground vehicle. Now, following the owner's manual recommendation, we're going to apply some dielectric grease to our terminal posts and clamps. And now, for the moment of truth, let's attempt to start the car. The battery is currently at 12 volts, so let's keep our fingers crossed since I don't have a way of charging it without removing it from the vehicle. Now that the car has started, we can observe that the voltage has increased to 14 volts as the car's alternator begins charging the battery. Referring to the chart shown earlier, my battery currently has approximately 30% state of charge. This indicates that our 55 amp-hour battery requires an additional 38.5 amp-hours of charge. Assuming that the car is charging the battery with 40 amps of current, it would take nearly an hour for the battery to reach full charge. As we go through these menus, we can see that the loss of power caused the volatile memory in the vehicle's computers to reset. Things like trip distance and fuel economy have been reset. Additionally, if the check engine light was on, it would have cleared any stored codes causing it to go out. Unfortunately, the odometer didn't also reset. To prevent the loss of volatile memory in a vehicle's computers, an OBD2 memory saver device could have been used. These devices are available on Amazon for around $20. However, it is important to use an OBD2 device, as the 12-volt outlet is disconnected from the car's electrical system when the car is turned off. If we take a quick look at the battery we just removed, you'll notice that it has both upper and lower fill lines on the front. By disregarding the maintenance-free label on the battery, we could have extended its lifespan by removing the caps and adding distilled water to the appropriate level. Here is an image from the owner's manual describing how we should be checking the electrolyte levels of the battery and adding distilled water as necessary. This is the end of the video. Thank you for watching. If you have any comments, questions, concerns, or feedback, please leave them in the comment section below.